Hello everyone, welcome to Computer Science. Today's topic is number system. So in this video we will be discussing about different kinds of number systems. Okay, so before that let's discuss what is a number system. What is a number? A number is a mathematical object used to count, label and measure. So number is something, it's an object that is used to count, to label and to measure things. And the number system, it is a mathematical way to represent number. So number is an object to count, label or something, and number system is a mathematical way to represent these numbers. Okay, and in our daily life, we are familiar with decimal number system that uses 10 symbols or digits. Normally, we are using the number system like say a number 12, 132, 354. All these numbers comes under the decimal number system. This decimal number system uses 10 symbols or it's known as digits. And this symbols as we know from 0 to 9. All the combinations of 0 and 0 up to 9 are known as decimal number system. This is the number system we are using in our daily life. Similarly, there are other number systems also. Each number system has its own symbols and methods for constructing a number. A number system has a unique base, which depends upon the number of symbols used. So, this point is very important. What is the base of a number system? So, this base is the number of symbols used in a number system is called the base or radix of a number system. Okay, the number of symbols used in a number system is called its base. So in case of this decimal, that is the normal number system we are using in our daily life, that is decimal. In the decimal number system, we are using 10 symbols from 0 to 9, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the radix of this decimal number system or base of this number system is 10. So this base is the number of symbols used in a number system. Next, these number systems are classified into two. First one is the positional number system. Second one is the non-positional number system. So let's check what is this positional number system. It uses digits for representation. Then the traditional number system is called a positional number system. So the number system, that is decimal number system, is a positional number system. Or the traditional number system is known as the positional number system. And it is in this number system, a number is represented as a string of digits. Okay, a number is formed by digits and each digit has a weight associated with it. Okay, each digit position has a weight associated with it. The number's value is equal to a weighted sum of the digits. Here, weight of a digit depends on the relative position of the digit. Let's take an example. Consider this number like 232. Okay, in this number we can see two twos. Here there is a 2 and here also there is a 2. But let's check the values or weights of this number. And here 232, this is the unit place. So the rightmost 2 is at the unit place, which means here the value will be just like 2, right? Then 3, this 3 is at the tens place. So its value will be like 30. This 2 is at the hundred place, right? So its value will be 200. So this 2 here, this 2 is weight is 200. This 2 here, its weight is just 2. Okay, a number's value is depends upon the relative position of that digit. The weight of the digit depends upon the relative position of the digit. Here we can see these are same numbers, but its weight changes according to the position of that digit. So this kind of number system is known as positional number system. Here this number's value is equal to weighted sum of the digits, and it is further classified into these all are kinds of a positional number system: binary, octal, hexadecimal and decimal also. And this is one example, 6354. Consider this number in 6354. We can see that this 4 is at unit place and this 5 is at tens place. So here its weight is 5 into 10. 3 it's at 100 place, so its value is 3 into 100. 6 is at thousands place, so its value is 6 into 1000. This is the positional number system. And next one is a non-positional number system. As it does not use digits for the representation, instead it uses symbols for the representation. So in positional number system, it consists of the strings of digits, but here it uses only symbols. It does not use any digits, but it uses symbols for the representation. A non-positional number system uses a limited number of symbols. So here it uses symbols, but it uses a limited number of symbols in which each symbol has a value. So 3 points we have discussed here. In non-positional number system, we are using symbols. We are using limited number of symbols, and each symbol is having a value. The position of the symbol occupies in the number normally bears no relation to its value. In positional number system, the value of that digit depends upon the relative position of the digit. But here in this non-positional number system, this there is no relation, but there's no connection with this position and the value of the symbol. Each symbol has a fixed value. The value of each symbol is fixed. So these are the major points, and one of the most important example of this non-positional number system is the Roman number system. So we are very much familiar with this normal number system, like this, all the capital letters and small letters. Here this stands for 1, this stands for 2, and this stands for what? This stands for 4, right? This for 5, this for 10, and this for 11, like that. So this is a normal number system. uh, so about the non-positional number system uses symbols instead of digit, and it uses limited symbols, and each symbol has a value, and this value is not having any relationship with the position. This value of each symbol is fixed. Roman number system is the example. And these are the symbols, limited number of symbols used in Roman number system. These are the symbols, and we will be familiar with at least these three symbols. And these are for higher values. L, C, D, M are used for higher values. So this is the values of the. Here we can see the values of the symbols in the Roman number system. Here this I for 1 and V for 5, X for 10. The value of L is 50. The value of C is 100. The value of D is 500. And the value of M is 1000. Okay. Um, this is about the non-positional number system. So we have discussed the basic, what is a number system, what is a base, and about positional and non-positional number system. Next, we are moving on to different number systems. We are looking in detail about decimal, binary, octal, and hexadecimal number system. Starting with the decimal number system, this is a number system we are familiar with. So it involves 10 symbols, 0, 1, 2 up to 9 to form a number. In decimal, to form a number, we are using this symbol 0 up to 9, and we are using the 10 symbols. So of course it is known as base 10 number system because it has a base 10. And it's also is a positional number system, as we know here, because it's a positional number system. So its weight of each digit depends on the relative position of the digit. That we know in positional number system, weight of a digit depends upon the position of the digit. Here also that applies. Then the place value. It's also known as a weight. Weight is also known as place value. Place value of each decimal digit is a power of 10. Okay. So here, if we take a number, each digit's place value will be a power of 10. Let's look that. So this shows the place value, and uh, I can write a number here, 5, 8, 4, 7, 0. Consider this number 58470.001. Okay, this is my number 58470.001, and here it shows the values of the positional value, the place values of this each digits of this number. So starting with the first digit left to the decimal point, its value will be 10 raised to 0, and we know that 10 raised to 0 is equal to 1. So its value will be 1. This is at the unit position, and here its value is 10 raised to 1, which means 10. This is at the tens position. This is at the 100 position. This 4 is at the 100 position. So its value is 100, which means 4's value is 400. And this 8 is at the 1000 position. This is 8000. Like that. This is at the fourth, 10 raised to 4, 10,000 position. Then to the right of the decimal point, we are having negative powers of 10. 10 raised to minus 1, 10 raised to minus 2, 10 raised to minus 3, etc. Okay. So this part is left to the decimal point. This part is up to the right of the decimal point, and here we are using the powers 0, 1, 2, 3, etc. And here we are using negative powers starting from minus 1. This is all about the decimal number system. Then consider an example, decimal number 5876. These are the weights associated with 10 raised to 0, 10 raised to 1, 10 raised to 2 and 10 raised to 3. And we are calculating the values like 5 into 10 raised to 3 plus 8 into 10 raised to 2 plus 7 into 10 raised to 1 plus 6 into 10 raised to 0. We get 5876 as the answer. Okay. And one more thing to note is that here the leftmost digit is 5, right? Leftmost digit is the MST. MST means it is the most significant digit because in this 5876, this 5 has a value of 5000, right? 8 has a value of 800. 7 has a value of 70. 6 has the value of 6 itself. So 5 is the most significant digit and 6 is the least significant digit, which means the rightmost symbol is the least significant digit. Next number system, moving on to binary number system. A number system which uses only two symbols, 0 and 1, to form a number is called a binary number system. So, this binary number system uses only two symbols, that is 0 and 1. Here, bi means 2. The base of this number system is 2. One thing I forgot, in decimal number system, decimal means, that is deca, that word comes deca, deca means 10. So, in this decimal number system, we are using 10 symbols. Like that, here, bi means 2. So in this binary number system, we are using two symbols. So its base is 2. So it's also known as base 2 number system. Like base 10 in decimal, here it is base 2 number system. And it's a positional number system. Then one more thing is that we use the subscript 2 to indicate that the number is in binary. Okay. To denote a binary number, we are using a representation like this, notation like this. We have to keep a subscript of 2. Okay, subscript 2 or if we simply write like 1101, we think it as 1101. Okay, we think that is a decimal number. By default, a number is considered as a decimal number. If we do not specify any base, we will consider that number as a decimal number. So to become a binary number, we have to write a subscript 2 over here. Then it becomes the binary number. If we simply write this 1101, it will become a decimal number. If we put a subscript of 2 here, then this will become a binary number. Each digit of a binary number is called a bit. Okay. In decimal, each digit is known as, that is digit itself, right? Digit itself. And here, each digit is known as bit. Bit means binary digit is known as bit. Okay. So the important points are, we are having two symbols. Our base is 2 and we are using a subscript 2 and each digit is known as a bit. Next, about it is also a positional number system. Here the place value. In case of decimal, the place value is powers of 10 because their base is 10. And of course, here base is 2. So the place value will be of each binary digit will be a power of 2. Consider a binary number 1101. So 1101 is our binary number. Their place value will be like 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 3. So here this one is the leftmost one is the MSB and rightmost one will be the least significant bit. And here the value can be found by 1 into 2 raised to 3 plus 1 into its weight 2 raised to 2 plus 0 into weight 2 raised to 1 plus 1 into weight 2 raised to 0. 2 raised to 0 is always a 1. Dot. Please note that point. 2 raised to 0 is equal to 1. So when we are adding these numbers, we will get 13. So this 1101 is equivalent to the number 13 in our decimal. If no base is specified, the number is interpreted as decimal, as I have already mentioned. If by default a number is considered as a decimal number, for other number system, we have to specify its base. The importance of binary number system in computer is that electric state on and off can be represented using 1 and 0. So we are using normally we are using decimal number system. Then why this need of this binary number system? Because in our computer understands only machine languages, that is a sequence of zeros and ones, that is known as the binary number system. Because computer is an electronic machine, right? So computer will be familiar with the electronic signals or voltages, on and off signals. This on and off signals can be represented using this 0 and 1, on by 1 and 0 by off by 0. So that is the importance of binary number system in computer. Next, moving on to the next system, octal number system. A number system which uses 8 symbol. Here, octa means 8. So it uses 8 symbols from 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. It forms 8 symbols. This is the octal number system. Here, base will be 8. Correct? So, of course, it is known as base 8 number system. Octa means 8. This number system is called octal. Base of this number system is 8 and hence it's also called as base 8 number system. Consider an example 236 subscript. 236 we are added a subscript of 8 over here, which means this 236 is an octal number system. If we simply write 236, we will be thought as a decimal, it will be thought as a decimal number system, decimal number 236, but here it is an octal number 236. And of course its base is 8, so the place value will be powers of 8, 8 raised to 0, 8 raised to 1, etc. The number 236 can be written in expanded form as from starting from this unit digit. The weight of 6 is 8 raised to 0, weight of 3 is 8 raised to 1, the weight of 2 is 8 raised to 2, like that. And the value, we multiply this weight with the number 2 into 8 raised to 2 plus 3 into 8 raised to 1 plus 6 into 8 raised to 0, we will get 158 as the answer. So 236 is our octal number, its corresponding decimal number is 158. Then about fractional numbers. For fractional numbers, we know to the right of the decimal points, the powers will be of negative powers. Okay. So here we are using negative powers of 8, right? 8 raised to minus 1, 8 raised to minus 2, etc. Consider an example 172.4. So please note in the decimal, in an octal number, the maximum, the highest number should be 7. A decimal number contains the combinations of 0 to 7 numbers. Okay. Then consider this example 172.4. We cannot use an 8 in this octal number. We cannot use a 9 or something. Okay. Numbers up to 7 is allowed here because only 8 symbols are used in octal system. So 1724 is our number and we have weight 172.4. So here comes a decimal point, and to the right of the decimal point we are using negative powers 8 raised to 1. To the left of the decimal point we are using 8 raised to 0, 8 raised to 1, 8 raised to 2. So by multiplying and adding we will be getting the answer 122.5. So 172.4 octal number is equivalent to 122.5 decimal number. Moving on to the last category, hexadecimal number system. Here it uses 16 symbols. They are from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And here we got 10 numbers, right? In decimal. 10 numbers. We got 10 numbers. And after other 5 numbers are, other 6 numbers are A, B, C, D, E, F. To form a number is called hexadecimal number system. So hexadecimal number system uses 16 symbols, of which 10 are digits from 0 to 9 and 6 letters from A to F. Here the base of this number system is 16, as there are 16 symbols in this number system. Hence this number system is also known as a base 16 number system. In the system, the symbols, so we know the values of up to 0 to 9 the same, right? Then value of A, B, C, D, E and F is respectively 10, 11, 12, 13, 14, and 15. Hexadecimal number system uses 16 symbols. Actually, the values are from 0 to 15, but we are using 10 digits and 6 symbols, I mean letters. 10 digits up to 0 to 9, and the remaining letters for 10, 11, 12, 13, 14, 15, we are using A, B, C, D, and F. Consider this hexadecimal number 12AN. And a hexadecimal number will look like this. It's a combination of digits and symbols up to A, B, C, D, E, F. Okay. And we have to specify a 16 over here. 12AF is a hexadecimal number. And we can use this bracket, or either we can use like this, or just write this 16 as subscript. No need of bracket using this parenthesis. Okay. Weight will be, of course, its base is 16, so the weight will be, of course, a power of 16. 16 raised to 0, 1, 2, etc. And to the right side of the binary digit, it will be 16 raised to minus 1, 16 raised to minus 2, etc. The number can be written in an expanded form as, let's look, a number 12AF, right? So starting from the unit place, 16 raised to 0 is the weight, 16 raised to 1, 16 raised to 2, and 16 raised to 3. Multiplying and adding, we will get 4783. So the number 12AF, hexadecimal number 12AF, is equivalent to the decimal number 4783. Importance of octal and hexadecimal number system. So we know that this binary decimal number system is we are using in our daily life, and binary number system is using because computers understands only this machine languages, because it's an electronic machine, and it's a 0 and 1, like electric on and off symbols. Okay, on and off signals. It's similar to on and off signals. So then what is the need of this octal and hexadecimal number system? Digital hardware uses the binary number system for its operation and data, but representing the numbers and operations in binary form requires too many bits and needs a lot of efforts. So writing all these operations and all these numbers in binary, that is the sequence of zeros and ones, it requires too many bits and also lots of effort. So here this octal and hexadecimal is somewhat simpler than this binary number system, because with octal the bits are grouped in threes. So this, if our binary number is having 3 bits, equivalent octal number will be having a single bit. Okay. uh, to convert a binary number into octal, we can group the binary numbers into 3 and replace this 3 bits with a single octal digit. So like that, this octal number will be shorter, right? For in case of hexadecimal also, here we are also grouping this binary number, but here we are grouping it into 4. So one hexadecimal digit is equivalent to 4 binary digits, for binary bits. So easily we can say that the size of this number will be reduced. That means bits of the numbers will be reduced. It requires only a fewer number of bits than the binary. With octal, the bits are grouped in threes, and with a hexadecimal, the bits are grouped in 4, and these groups are replaced with a respective octal or hexadecimal symbol. This conversion process of binary numbers to octal and the hexadecimal system and vice versa are very easy. The shorthand notation is widely used in the design and operation of electronic circuit. Okay. So this electronic circuits, of course, need binary, but we are using this hexadecimal numbers because we can convert this hexadecimal numbers, hexadecimal and octal numbers into binary very easily. Okay, and this hexadecimal or octal numbers are using very fewer number of bits also. So this is the importance of this octal and hexadecimal number system. Okay. So far we have discussed what is a number system, what is a base, positional and non-positional number system, then what about a decimal number system and the octal number system, hexadecimal number system, and binary number system. Hope the concept is clear. If you are having any doubts, comment me. Okay, thank you.